Welcome to this Maths Heroes video. My name's Christine. Common misconception that I see often with students in secondary school is when you start to do 10 to the power of -3, they think that this is a negative number. Well, last week I had a secondary student who actually said that to the right of the decimal point, that over here was negative numbers. They were negative numbers. So we had a bit of work to do, not only on place value, but decimals. And he actually came to me because he wanted to do decimals. So this question, the answer of 2072 came from it was 56 times 37, and from that we had to work out what 5.6 or 5 6/10 or 7/10 would be. So they told us that this one was 2072. And how could we work that out? So we spent quite a bit of time with a 10 frame, looking at, what happens when we divide and multiply by 10. So we eventually got to the point where he realised that this was the same as that, and that he could slide this 2 places over and get an answer of 20.72 hundredths. So that's just a bit of the background, because today we started talking about decimals. And you can see here, my question to him was, and I'll just move this over. Get rid of that bit. So the question was, he didn't understand where all the decimals came from. Is that right? Yep. And so I did, okay, well, let's do 3 shared between 4. So we started here with 3 shared between 4. And you can see he started to draw 3 boxes, and he shared them down here with 4 people. So person 1, person 1, person 1, person 2, person 2, person 2, person 3, person 3, person 3, person 4, person 4, person 4. So he realised that they got 3/4 each. We eventually got to that. I said to him, did you notice that the question, the answer is actually in the question? We talked about this division symbol and how it relates to also being fractions. And so he was quite surprised that that actually happened. But the problem was, that didn't tell him that it was as a decimal. I said, so what do we need to do if it's going to be a decimal? And so he realised he had to draw boxes again. So this is his attempt. And this time, because he had to do decimals, he knew that they had to be tenths. So he drew boxes, and he put all the numbers in, and he worked out that he had 2 left over here. And I said, I can't read any of that. And I said, let's draw it a little bit bigger. And that's where we came over to second whiteboard to find, so we drew big boxes, and he went through and he gave everybody pieces, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And again, he had these 2 remaining boxes. So we then had a whole discussion about how we were going to share these last 2. So what I'd actually started with was 3 of these deci pipes. So I had 3 of these. These are ones. And over here, these are tenths. These are hundredths. Just like that. And these are thousandths. So these are little washers and pieces of PVC pipe that have been cut down to size. So we had been through counting, 10 of these pieces fit into one of those for all of the sizes. So the fact is that 1 big equals 10 littles, or vice versa, 10 littles equals 1 big. So he knew that he had to break them down, and then we discussed about what we would actually call them, and we counted, because each box would have had 10 in them, that these these were now hundredths and these were tenths. Let's do a pinky colour. So we worked out that they were tenths. We then had to break them down so we could count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we knew that these were hundredths, and he could see that he could get 5 pieces of size 100 and 7 pieces of size a tenth. So the first thing he did was he counted his tenths up. So he said, okay, I've got 1, 2, 3, 4, 5, 6, 7. So that's where he got that first 7 tenths from. And then once we'd broken up the hundredths, they each got 5 hundredths. And we worked out that would be 75 hundredths if I wrote it like that. So then we had the decimal, and then we went through the actual division. So this was step 3. So we found the decimal, but we also looked at the division. So how much have I got to share? 3 things. So I actually physically had the 3 poles in my hand. So I had 3 poles in my hand. Can I share that between 4? No. So they didn't get any whole poles. And I said to him, how many of these tenths would I get for my 3 poles? And he said, well, there's 10 in each, so that's 30. And then we went through and we actually looked at dividing 30 something into four. So we went through 4, 8, and we finally got up to 28. And so there were 7 pieces that they would each get. So those are the 7 tenths. And there were 2 left over. So the first regrouping we made 30 tenths. So I'll just do a little longer pipe like that. I used 28 of them. So 28 used. And with 2 left over, 2 remaining. And that gave us 7 each. So that's the 7 that he wrote up there. And I said, okay, well, if you've got 2 tenths, how many hundredths do you get? And then he wrote, oh, I get 20 hundredths. So that is the 20 hundredths there. And I said, okay, well, if we've got 20 somethings to share between 4 people, how much do you each get? And that was 5. He knew that then we each get 7 tenths, and then they would each get 5. And it just showed me how important it is for us to model in this one example. I did it concretely with the deci pipes here. I did it pictorially with my tens frames, and we did it here with the boxes as well. And then we actually did the abstract, which was the division. So he could see how all 3 made the same answer and he could understand it. And he the thing that blew him away was actually this step here. This step here, that 3/4 came from 3 divided by 4. And we mucked around and we did things like 167 divided by 42. And that came 167 by 42 is 167 40 seconds. So we made up some silly ones like that. But this concrete or do, draw, dream, concrete pictorial abstract doesn't happen in isolation. So we need to see it as something that I physically held it in front of him. He could count the blocks, the deci pipes. We drew the pictures, and then we actually did the division together. And that gives him a chance. And he was absolutely thrilled. He actually got it. I don't pretend that one example is going to make it, or everything wonderful and rosy. We've got to do so lots more practicing, but it was a great start. So I hope you got something out of this. I hope it made you see how we can weave like a DNA thread, that whole CPA do, draw, dream. That's what I call learning is 3D, um, for our students to actually understand what's going on and not just follow an algorithm. Thanks for watching. Look forward to seeing you next time. And remember, everyone is a maths hero. Bye for now.